The topic of today's lesson is prime factorization and looking at prime numbers. In front of us, we have a table of numbers 1 through 50. Very short table. Let's perform the following algorithm. Algorithm means a series of repeatable steps. Step 1, just based on these instructions. Cross out number 1 since it's not a prime number. Let's cross it out. Before I go there, let's discuss what prime numbers are. Prime numbers are those special numbers that have only two factors. They're those poor numbers that have only two divisors, two factors, number 1 and itself. We're going to look at their examples. Prime numbers are opposite of composite numbers we learned about last week that have many different factors. So let's look closely at prime numbers. We have a table of 50 from 1 through 50. Let's first cross out number 1 since it's not a prime number. Yes, number 1, even though it's a very poor fellow, it's not considered to be a prime. Except step 2, except for the 2 itself, cross out all the remaining numbers that are divisible by 2 and have 2 as a factor. So let's circle 2, except for the 2. Let's cross out all the numbers that are factors of 2. And of course, these are all the even numbers. So let's go. All even numbers are out. All even numbers are out. All even numbers, cross out. All even numbers, cross out. Those are all the numbers that are divisible by 2. Except, next step of the algorithm, except for 3 itself. Cross out all the remaining numbers that have 3 as a factor. So let's highlight number 3 itself. Let's delete this guy. Let's highlight number 3 and go ahead and cross out all the multiples of 3, which are part of multiplication table. So 6 is already out. 6, let's cross out. 9, 11, no problem. 12, already out. Oops. Sorry, guys. 12 is out. 13 is in. 15. 18 is out. 21 is a multiple of 3. 24 is out. 27 is another multiple of 3. 30 is already out. 33, of course. 3 times 11 is 33. 36 is out. 39, 3 times 13 is out. 42 is already out. 45, also multiple of 3. 3 times 15. And that's it for now. Why do we not have to cross out numbers that have 4 as a factor? Because all even numbers will be already out of our list. Look, all multiples of 4 are even numbers, and we cross them out in step number 2. Finally, not finally, we have more steps. Except for 5 itself, cross out all the remaining numbers that have 5 as a factor. Let's proceed. So 10 is out, 15 is out, 20, 25, 30, 35, 40, 45, 50. What an easy job we had. Let me scroll down. Except for 7 itself, let's cross out all the remaining numbers that are multiples of 7. Let's do that. Except for 7, let's cross out 14, 21, already out, 28, already out. 5 times 7, 35, already out. 6 times 7, 42, already out. 7 times 7, 49. Let's cross that out. Wow, why can we stop crossing out numbers that have 7 as if we can stop after? The reason is multiples of 6 have already been eliminated because we eliminated multiples of 2 and 3. You see, multiples of 2 and 3 are also multiples of 6. And since we eliminated those, we don't have to go through multiples of 6 or 8 or 9. If it's not divisible by 3, it will not be divisible by 9. So let's highlight what is it that we have left. We have 2, 3, 5, 7, 11, 13, 17, 19, 37, 47, 29, 31, 41, and 43. All the numbers that we have highlighted in yellow are prime numbers. Prime numbers are only divisible by 1 in the number itself. I suggest you memorize those prime numbers. There is another small thing that you can learn. We have some concept called twin prime numbers, or twin primes. And those are the two primes that are next to each other on a number line, and their primes. So for example, 2 and 3 are twins. There are some others, but they're farther out. What else is, what other numbers are twins? List all the twin primes less than 50. Differences too. Sorry, they're not next to each other. They're 2 apart. So 5 and 7, that's the first one. 11 and 13. So let's write them down. 3 and 5, 5 and 7, 11 and 13, 17 and 19, and I believe 41 and 43. That's another pair of twins under 50. My friends, let's move on. The factors of 12 are 1 and 12, 2 and 6, 3 and 4. Which factors of 12 are primes? Well, we know 2 and 3. 6 is a composite, 12 is a composite, and 4 is a composite. Now, look at this interesting word. This is a word from the world of algebra. Express 12 as a product of prime factors. Only prime factors. Let's go. We have 2 times 3. That gives us 6. To get to 12, we need another 2. Typically, we write down prime factors in increasing order. 2 times 2 times 3. And voila, this is a prime signature for, this is a prime signature. Let me style, no fill, transparent. This is a prime signature for number 12. Find prime factorization of 72. This is a very important example, so pay attention, friends. Find prime factorization of 72. We can use 2 methods. Method 1, we use a factoring tree. Why is it called factoring tree? Because it kind of looks like a tree of many, many branches that branch out of themselves. And method 2 is called continuous division. Now, I will show you in action what this looks like. You need to understand one thing: no matter which method you use, you will end up with, of course, the same list of prime factors. Let me go over the algorithm. By the way, my favorite method is method 2, continuous division. Why? It doesn't take as much real estate, as much space on your papers. So let me focus on this example, 72. Let me mimic what the book also showed you. 72, the first step, we're going to draw a vertical line to the left, and we're going to draw a little horizontal line. Sometimes it's called T because it reminds us of a letter T. So let's write down, so we don't forget, the prime numbers under 20. I think that's enough for the purpose of this exercise. 2, 3, 5, 7, 11, 13, 17, 19. That's all we need so far, friends. That's all we need. Step 1, 72. Let's divide it by the smallest prime. The smallest prime in this universe is number 2. How do I know it's divisible by 2? 72 is even. 72 divided by 2 is 36. We write the quotient underneath 72. We loop back. Let's now divide 36. Okay, it's divisible by 2. Let's start with the smallest prime again. 36 divided by 2. You write that 2 to the left. What is the quotient? We know the answer to that is 18. We write 18 underneath. Again, we ask ourselves the same question. 18 is divisible by which smallest prime? And the answer is 2 again. The quotient is 9. We ask ourselves the same question. We keep looping back. Which smallest prime is 9 divisible by? Well, we know it's divisible by 3. 9 divided by 3, the quotient is 3. Note, friends, we are not finished with our continuous division. 3 is also divisible by, the smallest prime is 3. 3 divided by 3 is 1, and now we are done. Only when you get down to the quotient of 1 is, you know, it's a self-checking mechanism, you finished your continuous prime factorization. I've highlighted all the primes, which are already listed for us from smallest to the largest. And 72 is a product of 2 times 2 times 2, which is 8, times 3 times 3, which is 9. So 8 times 9, we know it's 72. Let's continue with examples at the bottom of this page. Number 4, let's divide 15. Actually, 15 is not such a difficult number. We know 15 is an easy product of 3 times 5, and we leave it at that. What about 50? Well, let's use our continuous division method. 50 divide in a continuous way. Step 1. You ask yourself a question. 50 is divisible by which smallest prime? Of course, it's even. 50 is divisible by 2. Quotient is 25. You write it down. 25, you continue to divide that quotient. 25 is divisible by which smallest prime? It is divisible by 5. The quotient is, the answer is 5. You write it down. You are not finished. 5 is divisible by which smallest prime? It is divisible by 5. 5 divided by 5, we have 1. We know 1 means we are done. Only when you arrived at the quotient of 1, you know you finished your division process. Let's collect all the primes that we've gathered on the left column, nice and organized for us, and let's write it down in the order from smallest to the largest. 2 times 5 times 5. Very good. We can even say equal sign. 36 is our next example. Let's quickly split 36 into a product of primes. Let's start by asking ourselves the same question. 36 is divisible by which smallest prime? It's divisible by 2. We've done this already. We've done this in our very first example. Right here, friends. Right here. So 36 divided by 2 is 18. You write down your quotient underneath 36. You continue dividing. 18 is divisible by, the smallest prime is 2. Start with the smallest prime, always. That's my recommendation. 18 divided by 2 is 9. 9 is divisible by 3. 9 divided by 3, the quotient is 3. We are not finished. 3 is divisible by what? It's divisible by 3. 3 divided by 3, we know it's 1. And only now we are done. Let's collect all the prime numbers on the left into our collection and write them down. 36 equals the product of 2 times 2 times 3 times 3. Notice, unlike the previous exercise we finished in our earlier chapter on factors, here our factors are prime numbers only. Only the basic primes. This, my friends, is called prime factorization, and we will be using it all the way through middle school and high school. Very useful tool. Let's practice. Now, the next topic I want to introduce is something we call exponent. Right here is a very new concept, hopefully new to all of you. We read this as 2 to the 4th power. Some people also say 2 to the power of 4. What is the value? This mathematical notation means that we multiply the number, which we call base. We multiply the base by itself 4 times. It tells you 1 time by itself, 2 times by itself, 3, and 4. This is what it means. Multiply this number by itself 4 times. And I will show you how to easily calculate this. 2 times 2 times 2 times 2. Think about this. 2 times 2 is 4. Another pair, 2 times 2 is 4. 4 times 4 is 16. 2 to the power of 4 is 16. How do we read this? The number at the bottom is called the base, the foundation. The little cute small number at the top is called exponent. Exponent. And that exponent tells us how many times we multiply this number by itself. So, if the exponent is 3, we multiply 1 time, 2 times, 3, 2. So we multiply 2 times 2 times 2, which, by the way, is 8. Find the value of 4 to the third power. Again, 4 is the base. That's the number we keep multiplying by itself. How many times? The exponent tells us 3 times. 3 times. Let's go. 4 times 4 is 16, and times another 4 is 64. Next, part C. Find the value of 10 to the 6th power. Notice 6th power is this little 6 on top, which means we must multiply this base by itself 1, 2, 3, 4, 5, 6 times. And that results in beautiful 6 zeros. 1, 2, 3, 4, 5, 6, and that is, of course, 1 million. 10 to the 6th power is 1 million. Why do we use exponents? One of the basic reasons, it saves you space. It saves you space on your paper. Mathematicians are lazy. We don't want to write down too much. We don't want to take too long. We write only what is necessary to free our time to think of bigger problems. And I encourage you to do the same. So let's look at number 6. Find the value of each of the following. Friends, I suggest you write it down out at first. 3 to the power of 3, or 3 to the third power, means multiply 3 by itself 3 times. 7 to the power of 2, multiply 7 by itself 2 times. 3 to the power of 3, by the way, is 27. Example C. 3 to the power of 3 times 7 to the power of 2. Well, we just learned 3 to the power of 3 was 27 times 49. I will let you complete that math. 1 to the power of 7. Before you get confused, I will not give you any rules. Let's first write it out. I encourage you to write it out. What is the base here? The number at the bottom, at the foundation, it's number 1. How many times we multiply 1 by itself? 7 times. 1 times 1 times 1, 4 times, 5 times, 6 times, 7 times. No matter how many times, the answer will still be 1. 10 to the power of 3. I encourage you to write it out. And of course, that simply is 1,000. And 10 to the power of 1, it just means you multiply 10 by itself one time, which is simply 10. Now, number 7 is asking you to do the opposite operation. We need to shrink the statements. We need to compress them and make them nice and beautiful using mathematics. Friends, take a look. We have 2 times 2 times 2. We have, strange. We have, let's just do this. 2 times 2 times 2. And we have 5 times 5 times 5. That means we multiply 2 by itself 3 times 5 multiplied by itself also 3 times. So it's 2 to the power of 3 times 5 to the power of 3. Next question is 5 times 3 times 3 times 5 times 7. Let's list them from smallest base. We have 3 multiplied by itself 2 times 5 multiplied by itself 2 times 7. I'm going to make some space right here for C. 11 times 7 times 11 times 7. Let's look for same bases. Let's find lookalikes. We multiplied 11 by itself 2 times, power of 2, times 7 multiplied by itself also 2 times. And finally, what do we have here? Let's evaluate this expression. What do we have? 3 times 2, okay? Let's write it down as 6 times 10 multiplied by itself 5 times. And we have 6 times 10 to the power of 5. It is perfectly appropriate to leave your answer using exponents. It's nice and beautiful and very short. Number 8, find the value. Find the value means calculate. So 8 times 10 to the 4th power is 8. 1, 2, 3, 4 zeros, which is 80,000. 32 times 10 to the 6 is 32. And 1, 2, 3, 1, 2, 3. 6 zeros, which is 32 million, and 806 times 10 to the power of 7 is 806, followed by 7 zeros. Let's put them down. 1, 2, 3, 4, 5, 6, 7, and let's create our periods. We have 8 billion, 60 million, and so on. 8 billion, 60 million. Now, show the prime factorization of 72. This is our old friend, 72. We just completed it on the previous page. So instead of writing it this long, which of course takes way too much writing, we make it concise and beautiful using exponents. How many times 3 was multiplied by itself? 2 times. How many times was 2 multiplied by itself? 3 times. Therefore, 2 to the power of 3 and 3 to the power of 2. Now, this particular exercise number 10 will take us some time. And I will solve examples B. Let me highlight them. I will solve examples B and D for you, my friends. So here is my little whiteboard. I'm going to make it this way so I can write down prime factorization. Okay. All right. So let's do prime factorization for 24. Again, my favorite method is continuous division for one simple reason. It allows for very little real estate on your piece of paper. I've seen children making trees that go off the edges and it's very uncomfortable. So let's start with 24. I'm going to start it with a different color just to kind of make this example stand out. So 24 divide by. Let's think of our list of primes. The smallest prime, of course, is 2. 24 is even. 24 divided by 4 is simply 12. Also divisible by 2. 12 divided by 2 is 6. 6 divided by 2 is 3. 3 is still divisible by 3. Now 3 divided by 3 is 1. And now we know we're done. Let's collect our prime factors for 24. Somehow it doesn't work, my highlighting tool. So let's just write it down. 24 is simply 2 times 2 times 2 times 3. I'm going to write it down at the top. 2 times 2 times 2 times 3. But we need to start using exponents, and therefore it would be just 2 to the power of 3 times 3. And that is the prime number signature for number 24. It's a unique signature for this number, just like your retina, and your fingerprints are also unique just to you. Now, the next example is 82. Let's continue. 82. You see how much I can fit on my piece of paper when I go with little continuous division. Again, the smallest prime is 2. It's an even number. The quotient is 41. 41? Well, 41 is a prime number. I know that. It's only divisible by 1. 41 divided by 41. The quotient is 1. And I know I am done. So 82, my friends, was not a big deal if it only has a few prime factors, 2 and 41. 82 is not a prime, okay? 2 and times 41 makes 82. And I hope you understood our prime factorization topic.